Good morning. Thank you for joining us today for our webinar for October 2017. And today the subject we're looking at is testing for compliance. My name is Katie. I look after all digital communications here at CABE, and I'll be guiding you through this morning's session and answering any questions that you may have. So in terms of any questions, it's an interactive session this morning. So what we ask you to do is on your screen, perhaps on the right or at the top, there'll be a question panel, and you can just send any questions in to us via just using your keyboard, and we will pick those up as we go along. So we'll either respond directly if it's at an appropriate point in the session, or we may look to do the questions at the end. But either way, feel free to send any comments that you may have. We've also got a couple of polls that are going to pop up on your screen. Again, we just ask that you get involved and respond to those, and it gives us an idea based on the question that we'll be sending through. If you're on Twitter, hashtag CABECPD. Your presenter today is our Technical Director, Kevin, and with his vast amount of expertise, he'll be leading you through this morning's session. So without further ado, I'm going to hand over to Kevin for the presentation.
Thank you, Katie. Good morning. We're running without webcams today, just because you shouldn't really have to suffer my ugly mug at 8 o'clock in the morning, and because it does tend to improve the sound quality and the rest of the presentation. So we're going to look at compliance and how we can deal with compliance with standards by looking at the physical testing regimes and what we may have in place as a measure to give us some factual evidence to make judgments rather than maybe subjective decisions. The first thing I'm going to do then is to try and make sure I'm pitching at the right sort of audience. So as we've done on a few of these webinars, I'm going to ask you to let me know what your role in the construction process is. So I'm going to give you the option of the client or their representative, the designer, a contractor, a building control, or a warranty provider. So you'll see shortly a poll coming up on your screen. If I could ask you to vote on that, then it'll at least give an idea of where we sit, and you as an audience will then have an understanding of who else is actually connected and listening today. So at the moment, I've got about 2/3 of you have voted so far. I'll leave the poll open for a few more seconds. I appreciate not everybody always wants to commit, and obviously there are some blurred lines here where people may operate in different areas. So, okay, I'll close the poll off there. And now, hopefully, through the miracle of technology, at some point, you should now be seeing the results of the poll. So about 2/3 of you today are working in building control. Another, I suppose, just over a quarter are either the designer or the client, and then we have a proportion working for warranty providers, but nobody really from the contractor, developer, builder side with us here today. Okay, so we'll hide that, drop that off. Hopefully you'll now pop back to the screen that I'm looking at, and we'll start looking at the rest of the presentation. So the first question is, when we're testing for performance, what sort of level of performance are we actually looking at? Are we looking at the very best, which might be what the client and the designer are hoping to achieve? Or are we looking at something at a much baser level that still does the job and performs as we need to and meets our basic statutory requirements? And I think in a lot of situations, what we see as a testing regime applied to the construction process is actually looking at the basic construction and the basic standards that are set by statute, rather than maybe something over and above that. So when we look at how we can go about testing in real terms, we can test something in situ at completion, which is possibly the clearest way of giving us an indication of what the actual performance is likely to be. But we can also do modeling and testing perhaps in a theoretical way, and we can then do comparative testing between situations, necessarily reflect how things are going to work in practice on a construction site building. So if we look at the in-situ completion type testing, in terms of establishing whether we meet that statutory requirement, whether we comply with the building regulations or something else, this is the easiest way of actually proving the point and showing clearly that we have a level of compliance. It measures actual performance at a point in time, albeit at the completion point, so it can give us a clear indication of compliance or not, and it provides some reassurance to the client and the owner. But it is only what occurs at a point in time, normally completion of the project. And we have to be aware that over time, we will tend to see the performance drift away and not be quite as it was intended in the first place. At completion, in the construction sector, testing things like air tightness of drainage systems, gas tightness of flues, air pressure testing, sound insulation, all can be applied to the actual building in process and give a clear demonstration of where we are. Some of the other issues that we might want to be able to test, really the technology isn't quite there for us to do it. So to do a thermal appraisal of a building in terms of a test at completion isn't yet possible, although technology in terms of thermal imaging is moving a long way towards it. So at some point in the future, more aspects of the building may be available for actual completion stage testing. If we then look at the sort of indicative type of test, so testing something now out of the building structure in laboratory conditions, it can give us an indication of the expected performance and therefore a level of compliance. But the difficulty is replicating the test or the modeled conditions actually in situ on site. And quite often that sort of test regime, where it's done under laboratory conditions, the actual practicalities of installing that same construction on site and making sure that we've got the same materials installed in the same way is not always totally clear and totally possible. So we have to be aware that how something performs on site is not necessarily how it's going to perform in the real world. And I suppose one of the best examples of that is maybe fire protection to structural elements of a building. In a test situation, something can be tested to show that in the test it will achieve an hour period of fire resistance. But in reality, if the fire that it's actually exposed to is different in nature, is more concentrated in one point than another, has different temperatures involved, then the actual performance may be different than the model would have led us to believe. And then the other thing we tend to do is comparative testing, which a lot of it can be using real data, some of it can be calculation driven, and a lot of this actually then gives us a comparison between buildings, and it can give us a comparison between a set standard, but it doesn't necessarily give us an actual indication of how things are going to be used. And this is when we start testing things and looking at calculation regimes based upon standardized lifestyles or standardized uses of the building, which make assumptions in the way in which they're put together, which when we put real people into the building actually using it in anger, we end up with a different sort of a solution. And therefore it gives us a comparison. We can compare to a target, but it doesn't tell us anything about how the building is really going to perform in practice. So one of the limitations we have on the ability to test is actually the technology that's available. So we need something as a test that is repeatable and will give consistent results with robust equipment that we can use on a building site. Now, the illustration here is obviously a firefighter using thermal imaging equipment. But in the ideal world, we would not only be able to use thermal imaging to look at energy, but perhaps we would have some sort of tool that could look at the building and measure fire safety and maybe examine a structure sometime in the future to look at whether fire stopping is in place or missing without the need to take things apart or be there at a key stage in the construction. But for the testing regimes we have, we are limited by the equipment that is available to do a repeatable and measured test. And then we need to understand what we're looking at and how we measure it. I've mentioned already a couple of times about thermal imaging. There needs to be an understanding of how that works, because the timing during the day and during the year of thermal imaging can be critical. If an elevation has been exposed to bright sunlight all day long, when you apply a thermal imaging camera, it is going to look like a very hot surface, which could well look as if the building is leaching a lot of energy, whereas in fact what it's done is all day long absorbed radiation from the sun. So understanding what we're measuring it, how we're measuring it, and how we interpret the results we get is quite critical. And quite often, to make this technology available to work on a building site, it needs to be absolutely foolproof in the way in which it's designed and works. So what we tend to look at when we're looking at testing regimes is a degree of competence of the person doing the testing. We're not expecting any one party in the process, and 2/3 of you listening today are building control. We're not expecting building control to be experts in absolutely everything in the process and be able to carry out sufficient testing of everything that's there in the process. So we're looking at relying on competent and normally qualified and certified individuals to do a lot of that testing regime for us. And as a result, we rely on third-party certification. Now, third-party certification works if it's based on a level of qualification and competence, and there is some form of audit trail and checking in how these things are produced. What's critical then is that people are trained how to do the testing properly, they understand the results they're seeing, and that the equipment they use is calibrated and there's a set methodology. Unfortunately, we have a regime at the moment when some parts of testing require parts of this, but not everything. Now, Part F of the building regulations deals with ventilation. And there's a regulation that requires that all mechanical extract systems need to have a test to show that the extract rate that's achieved with the fans and the ductwork and the louvers or whatever in situ is actually what should meet the regulations, rather than just what the rating of the fan might be. Now, the current regime says that the person doing that testing has to have calibrated equipment, and they have to do it following a methodology, but there is no subsequent requirement for any form of qualification or competence of membership of any overarching body. So there has to be some doubt cast upon how valid some of those results might be. And going forward, if we are looking at more testing and less subjective judgments, then we need to make sure that the people who are certifying are fully competent to do so, and obviously take on the liability and responsibility for the certification that they're giving. So when we're looking at the sort of things we get in terms of in situ testing at the moment, the typical sort of in situ tests that we see are drainage, air leakage, sound insulation, and ventilation. And with some of these, there are some key issues. So with most of these things, if we're looking at ventilation testing, drainage testing, there is no defined level of competence or qualification or even requirement to be signed up to any form of certification body or competent person scheme. So there's a query over who's actually doing some of this stuff. With air leakage, the testing regime and the people doing the testing regime are controlled and audited, but we only do sample testing. So we don't know for sure how each building is actually performing. And with sound insulation, we have moved to a regime where, although we do sound insulation testing, a lot of the time we go for somebody on site certifying that a particular construction has been used, and therefore avoid the need for a formal test at the end of it. So again, not totally buttoning up how we actually achieve the compliance level that we're looking for. So the next question then I'm going to ask you is to get a view on whether you believe that the on-site testing that we do is sufficiently robust and accurate in giving us detailed results. So this is going to be a straightforward yes, no, don't know question. I'll open that up for you to have a look at now, and hopefully that's working. So if you could just vote on that at the moment, please. It would be interesting to see where this actually sits. Okay, I've got about half of you voted so far. It's interesting as the voting proceeds, because what's quite clear from the voting pattern that I can see that you can't, is as the voting started, there were some very clear decisions very quickly in one way. Now it's settled down, the balance is slightly different. So I'll share with you the results so that you can see how that panned out. So in terms of do we believe on-site testing is robust and accurate, 29% of you have said yes, 47% said no, and 24% don't know. Now that actually, if you look at it from an industry perspective, is quite a worrying result, because it's suggesting that we accept a testing regime, but we're not actually happy with the results we're getting from it. And the point I was making as people were voting is in the first flush of votes, the first sort of 50% of people that voted, actually the no category stood and went up to about 2/3 of those attending today, and it sort of balanced down as people voted later on. But even so, just under half of you think that maybe the testing regime we've got on site isn't as robust and accurate as it perhaps should be. Right, so going back to the presentation then, what is also important when we look at how we install things on site and how we're working is, because buildings are becoming far more complex, far more services reliant, there is a need that if we put equipment into the premises, that we need to be able to make sure that that is running to its peak performance. So commissioning and setting up and testing is a critical part of the process, and therefore we tend to use the expertise of those installing the equipment in terms of the commissioning to make sure that it's actually going to run effectively. And this again is where a lot of the industry is covered by competent person type arrangements or commissioning certificates that are received from those installing the equipment. It puts the liability onto those who are certifying, but it's worth remembering that those who are regulating, if something is totally taken outside of the regime of the building regulations, say somebody is installing a gas appliance and they are on the gas safe register, then yes, that takes it out of the mainstream building regulation system. However, there is a need to check that those individuals are actually on the gas safe register and not just take somebody's word for it. If somebody's on a competent person scheme and certifies something as complying, although they are certifying to say it complies with the regulations, if building control bodies believe that there is a contravention, then it is still perfectly acceptable for them to pursue an enforcement to get things put right. So it does mean that there is this element of accepting a paper trail to show that elements of the building are actually performing properly. Right, I'm going to pick up on a couple of the quick questions that have come through. What percentage of building control and warranty providers do not think that on-site testing is robust and accurate? Well, thanks for the question. Unfortunately, I haven't got it broken down in that way. All I can tell you is that from the first poll, we had about 2/3 of the audience being building control, about 11% being warranty, and then overall across all of those people attending today, we've got this split of 47% saying they don't think it's robust and 29% thinking it is, and a 24% don't know. I don't actually know how that broke down into each individual profession. It might be something that would be worth trying to find out. I haven't actually got time to put another poll into the situation at the moment, so maybe during this or in the feedback after this webinar, you could perhaps give me an indication of where you think it is. I guess the question is coming because it's thought that maybe there's a different perception between those doing building control and those doing warranty about how accurate testing might be. I've also got a comment here to say that the last air tightness test I was involved with produced very poor results as there'd been an attempted burglary where one of the window seals had been compromised. And I think, yeah, again, this comes back to be perfectly honest, what are we testing to? Are we testing to some ideal, or are we testing to a compliance standard? Because when we look at air pressure testing, to achieve an air pressure testing in a new dwelling of something like a leakage of 10, it is possible still to have a gap in the construction equivalent to the size of about a 20p piece for every square metre of the external wall. So yes, if there are some seals that have been damaged, it would compromise the result, but it might still have passed a test or given a figure that enabled the calculation process to work. And it does mean that, you know, very quickly after the building's completed, if something changes, such as a window seal is damaged, the actual performance in use is still going to be significantly different than the test result. And those of you who've seen or witnessed testing undertaken for particularly for things like air tightness will see that actually during the test, certain parts of the construction, like the openal bit of background vents and things like that, can actually be sealed during the test. So again, it doesn't necessarily reflect how the building is going to work in use. It's more of a comparison. And yes, I think quite rightly it's been pointed out, particularly in Scotland, but it's the same anywhere else, that testing is to compliance standards, and that's all you can actually ask for. It would only be if the client and the designer stipulated anything else that maybe you'd look for a higher standard to be enforced. Right, so moving on, obviously there are, as I said earlier on, elements of the building that we simply can't test and where subjective judgments have to be made. Now, although it's not strictly speaking a test, if we are looking at dimensional criteria or something of that sort, then measuring against a set criteria can be a form of test. And we are starting to see now, particularly with building information modeling and the 3D modeling and the software available, that some of the dimensional bits and pieces can be tested, if you like, by the design and the software for compliance. So things in a design like a handrail height, the software can be programmed to make sure that the handrail height is correct and that holes in the floor are guarded and that sort of thing. And that to a certain extent means that the model of the building is testing against the standard by measurement, and then actually physically measuring the same element on site becomes a test of sorts. Where we can't do that is where we have to make some form of subjective judgment about whether or not something meets the standard. And perhaps the future of statutory control, to make it easier to understand so that people don't have difficulty with interpretation, as well as easier to actually apply and enforce, maybe to move more to a regime where things can actually physically be measured against a standard, as opposed to a subjective judgment or an interpretation being required of the regulation. So it may well be, as I say, that if the design has been assessed for compliance, then ultimately what we end up doing is checking the as-built construction against the design. And this is more akin to the last question that came in from Graham relating to the Scottish situation, where you have a plan, you have your warrant, and you should theoretically build to it. And again, then we're at a situation where if we know we have a design that should work, the actual checking and testing against that design on site only has to understand what they're looking at in the design if the competence has been used to assess the design rather than the work on site. Obviously, there's a whole load of concern at the moment about materials and their performance and testing regimes. And the two issues that run with any form of test of something, particularly in laboratory conditions in terms of the performance of material, is that the test that we apply must be appropriate for the way in which the material is actually going to be used. And then fundamentally, if we've got a test certificate that says something performs in a set way, that must be how that material is actually used in practice. And that's fine, and that works if we're looking at individual materials. But it does require a level of understanding of the test regime. So the example I tend to quote is testing for surface spread of flame across the surface of a wall or a ceiling. A lot of people quote a British standard test result of being class 1, class O, or whatever. When you actually look at the detail of the British standard, most of that testing is testing that surface material on a solid plastered and rendered background. And in the majority of buildings that we build now, we don't use solid backgrounds. We use some form of dry lining. So actually, although there's a test certificate that says X material will achieve a class 1, it will be under the test conditions with a certain background. If we're using dry lining, that test is no longer appropriate, and we have to look for one that is, which might be the European test instead. But we can't use the indication on a plastered background of how something will perform on dry lining. And critically then, if somebody gives us a certificate, we need to make sure that the way in which it's being used in a building actually reflects the test conditions. But the bigger problem with testing materials and performance is if we test individual components, they don't reflect how that combination of components is put together with other materials on a construction site. And because we have such a wide range of materials and manufacturers and suppliers available, it's very difficult to get one test that reflects every possible combination that could be used. So again, whenever there's a test certificate being put forward, it is important to make sure that that actually reflects how the item is going to be used in use within the building. And then we do have to look at the issue of what's the difference between the indication in a laboratory test to the actual performance in reality. And laboratory testing may be the only true option and can give us a base standard, is a good process for providing a comparison between materials. What we do have to make sure is that the methodology and the test itself is fit for purpose and reflects how the majority of these things are going to be put together and used. Again, the laboratory results have to be able to achieve repeatable, consistent results when using the same material to validate it. And then it has to be cross-referenced and validated to how we use things at work in the construction site. And again, here is a clear indication of maybe with some of the thermal insulation stuff that we're looking at the moment, how the indication from laboratory testing doesn't necessarily form what we find on site. And there's been a lot of work done in recent years about what's causing this gap in performance. Some of it is workmanship, some of it's installation, some of it's substitution materials, but some of it is also that the laboratory condition testing of a material isn't necessarily going to be the same as we see in use. So once you actually get a wind speed across a roof, the performance of it as a thermal element is going to be different than it might be in laboratory conditions. So some of it is using the laboratory as an indication, but not necessarily expecting that's going to be how the building is really going to work. And as I say, we have to make sure, and I've mentioned surface spread of flame and testing, we have to make sure that the testing regime we use is appropriate and that it replicates what's really going to happen in a building. Now, I don't know if any of you have seen video clips of fire door testing, but quite often you'll see a section of wall with a door or two in it put to the front end of a furnace, the fire started behind, and timing to see how long the fire door lasts. That's fine, and it gives us a good indication of what's going to happen in reality. But obviously in a real fire situation, a lot of those fires that the door is holding back in the very early stages are not a furnace firing at full blast. They are slow smoldering fires that start over a considerable period of time. So actually in reality, a lot of fire doors might last a lot longer from the ignition of the fire than would be indicated by a fire test, where it's looking at a slightly more advanced fire. So we have to look at the methodology. And I mentioned just now surface spread of flame. If you're looking to bring a new wall finish to the marketplace, then when you test, you actually test in a small box type room, and you would apply that material to the wall and the ceiling to carry out the test. So again, not necessarily exactly how you might be going to test the material or use the material. Right, we'll move on to another question, which is, have you ever had cause to query a test certificate that's been provided to you? So again, this one, there's a yes and a no. There's not even a I'm a not sure, don't know basis. So you should now just have a straightforward yes, no, I've queried it, or no, I haven't. And again, about half of you have voted now. So I'll leave it open for a little bit longer to see where we are. Okay. And I'm consistently looking on these votes. Once I get to about 3/4 of people voted, that tends to plateau off. So there's a good quarter of you there who don't necessarily click the button to vote, but that's not necessarily going to affect the vote. Right, so I've closed that. I'll let you have a look at the results. 72% said yes, I've had cause to query a test certificate. That is positive in some respects, but because it means the process is robust and people are querying what's put in front of them and not simply just accepting it. 28% haven't, but that might mean that everything they're presented with has been fine, or that they're not actually they're not in a role that's presenting them with test certificates. I haven't put in the next logical question, I don't think, which was, you know, of the ones you queried, how many actually had to be changed? But obviously there is a need to scrutinize what's being put in front of us. Right. So when it comes to these elements in use, one of the continuing factors is that we are using a component or a material in an appropriate way, which is reflecting the test conditions for what it's supposed to be. And then that's it. As far as building regulations compliance is concerned, that's the snapshot, which is like the MOT certificate on the day that the building was complete. And the continuing performance of the building requires servicing, maintenance and replacement of components in the same way that the car does once it's passed the MOT. And as a result, there's an education process there needed to say, although you've bought your new building, you've got your test result, there is a need for some continued effort here to make sure that it keeps performing as we'd expect. And obviously some of this performance we may be talking about could be critical. It could be life safety type features, particularly where compliance in the first place has been achieved by using something that has a limited lifespan, whether it's a treatment to a surface to give it an improved fire performance, or whether it's simply something like putting in a carbon monoxide detector, which in itself has a limited life and there's a requirement to continue to use it. So it is a continuing process and there is a need for education. So I'm now going to drop on and ask you another question. Let's pick up this one, which is, how do you believe buildings perform compared to the building regulations minimum standards? So this isn't necessarily just about the testing regime. This is, we have minimum standards. How do we really think buildings are performing compared to those? And with this, I'm simply asking, is it mostly perform as the standard, mostly fail to meet the standard, or mostly exceed the standard? So hopefully that poll's now open and you can vote. And this is really, how do we think buildings are actually doing? Okay, and the number of you voting is creeping up slowly. So I'll leave it open another 10 seconds or so. Okay, right, I'll close that poll off and let you have a look at the results. And I think that's interesting. And before the question pops up, no, I don't know how that splits down between building control and warranty providers. But as an industry as a whole, or at least a representation of it watching this webinar today, I think, you know, you could say, well, 70% of people there think we're meeting or exceeding the standard, so that's quite positive. But on the other hand, 30% saying that we're mostly failing to meet the standards is quite a worrying situation. And I think it ties into a question and a comment that's just dropped in that says housing is often built to meet the minimum standards. And those of you who've listened to me on webinars before will know that one of my bugbears at the moment is that we have minimum regulatory standards to build to, and people tend to use that minimum standard as a target, and therefore if they fail in any way, they fail to meet the minimum standard. And maybe we need to change the culture so that we have minimum standards, but actually the majority of people aim higher, and therefore even if they fail at that higher target, they still end up meeting a minimum level that's still suitable for use in the buildings. But it is a worrying issue that 30% of people say we're probably not meeting the standards. Okay, that's pretty much all I was going to say today. So I've now got time for any additional questions that you want to drop in. I'm fairly sure, Katie, that I've picked up most of the questions that have popped up so far along.
Yes.
I don't think you've seen anything else. So are there any further questions people want to just quickly type in and see where we go? If not, I'm going to have to assume that you're reasonably happy with where you've heard. Obviously, in terms of some of the statistics, there's a body of work to be done, and there are a lot of people working on that body of work in terms of whether we are performing and what's going to change as we move things forward. And I think in terms of standards, it's really a question of watch this space. Okay, do you get a record of this webinar to add to your CPD? It's not automatic because of the electronic format, so you'll have to add it onto yourself. Part P people are not supplying installation certificates. Yeah, it is a difficulty with some of the competent person schemes, particularly about the time lapse between the work being done and the notification going back to a building control body. And particularly the competent person schemes, the notification might not go to the building control body that's dealing with the rest of the project. But somewhere along the line, as well as the Part P certificate, the electrician doing the work should be giving a certificate to the property owner to demonstrate that the premises is actually safe. Right. There's a problem with the continuing process and maintenance, etc. I've dealt with many buildings which have been designed by architects with very clever systems introduced for fire safety measures and also heating and ventilation. It's been clear that once the buildings are handed over, the level of maintenance isn't met, and therefore the performance and the safety isn't perhaps what it should be. It is difficult. There is no continuing control over the building for the majority of building regulation matters, although interestingly the Building Act allows for it, it just hasn't been enacted. There is a sort of a continuing control in terms of fire safety under the Regulatory Reform Order and the continuing responsibility on the premises user. But that's why increasingly now, when we see a change to legislation, we get a regulation that requires this information to be passed on to the end user to highlight to them that they actually have to be able to maintain, service the building to keep it operating effectively. They need all that relevant information, but there's only so much that can be built into a regulatory process. There's a question here, does a person have to be suitably qualified to carry out electronic testing? The simple answer to the question is yes. Do they, if they're part of a part scheme and certifying, they will definitely have to be qualified. Theoretically, anybody can use the test equipment, but you wouldn't necessarily be able to issue a certificate that would back it up to show how it works. Okay. And then simple practical questions. Is there a copy of slideshow later for reflection? All of our webinars go onto YouTube, onto our YouTube channel after they're live, and they're there to be viewed whenever we want to move forward with that. And the final one, if it follows that if housing is being built to minimum standards, it will fall below them with the margins of error, poor workmanship, etc. Totally agree with that, Robin. The problem is the lack of effective site supervision and management coupled with transient trades. Yeah, absolutely true. And one of the big calls across the industry is consistently for a greater level of supervision on site, and possibly independent supervision from something like the equivalent of the clerk of works, or if there's an expectation that building control or warranty providers will do that additional expectation work, then we have to get to a realistic level of fees to pay for that level of work. Unfortunately, at the moment, most clients want to pay the bare minimum fee, which doesn't allow for a higher level of inspection. And yes, the comment which reflects what we were talking about earlier on, that it would be interesting in terms of some of these statistics to know perhaps how the different elements of the industry, the different professions within the industry view these questions that we've raised. And ordinarily, I would say that's something that perhaps later on we would look to ascertain from, particularly from our members, and maybe put in the journal. But some of you may be aware, some of you may not, that this actually is my last webinar for the association, and I'm actually leaving to go to pastures new. So I'm hoping it's something that maybe my successor will take forward. I'm sure Katie will pick up on. So I'm going to hand over to Katie to just wind up in a minute. But I just want to say this is my last webinar. I'd like to thank the solid core of you who attend most of these events, and obviously thank anybody who's new to today. I've done 3 years worth of webinars now. That's roughly 30 webinars. Around about 4,000 people have attended those live as they go out. And as we post them on YouTube, nearly 20,000 people have listened to them and watched them on YouTube. Webinars are a strange animal from my point of view, because I only get the written feedback in the questions. It's not to a live audience. So I have to just believe you're there and attentive. But I would like to thank you to that. And I wish my successors the very best in the future. So Katie, over to you.
Well, how do I follow that? Kevin, keep an eye on the comments that are coming in. There's some really great feedback for you there. Just let you read through those while I wrap up. So yes, I want to thank Kevin for his expertise today and for all the previous webinars that he's done. I hope that those of you who have joined us have found them informative, but it's not the end. We will be moving forward. Our next one is on the 15th of November, again a Wednesday, and we'll be looking at accessibility in commercial buildings. So you can probably get the idea now that we're going to be having some different speakers getting involved, all with different areas of expertise. Again, we've said it before, but we'll go out to you guys. If there's anybody out there listening that would be interested in delivering a webinar on any area of the built environment that may be of interest to our members, then please just drop me a message here at HQ, and we can have a chat if it's something that that you'd be looking to do. And just picking up on the comments regarding CPD records and viewing it afterwards, Kevin did say that yes, it will be available on our YouTube channel. You'll get an email in about an hour's time from the system, which will in effect confirm your attendance at this morning's webinar, and it will state in there that you were here. So in effect, you can use that as confirmation of your 1 hour CPD. So again, that's kind of about it. Thank you for joining us. Thank you for all your questions this morning. And I shall see you all in November. Thank you.